At Innovalia Metrology, we have been offering our customers the best products and advanced services in industrial dimensional metrology for 30 years. We manufacture coordinate measuring machines, tools, optical sensors, and measurement software. We provide optimized intelligent measurement solutions, turnkey projects, and consulting and quality control duties. Innovalia Metrology means innovation. We are committed to investing in new technologies that allow us to stay at the forefront of the industry. Our commitment is to offer you the best assets to raise the quality standards of your company and reduce production times as much as possible. We provide support to leading companies in key sectors, and we do so by focusing on internationalization. We assist our customers from our global headquarters, with instant availability and thanks to our wide network of international partners.
Unimetrik is a Spanish metrological service company, oriented to offering solutions for the industry related to calibration, measurement, and metrological engineering, and is currently exporting its technology in Europe and other relevant industrial countries all around the world. Among the metrological solutions currently offered by Unimetrik, the most relevant and also those that have been used in the XMANAI project are the metrological studies utilizing Optiscan and the M3 software. An optical measurement system used to capture and analyze point clouds of industrial parts and components that are provided for testing the tolerances, taking into account the accuracy required in each case. Companies dedicated to manufacturing parts and components for energy, aeronautical or automotive sectors are receiving dimensional quality requirements and tolerances from large companies that can only be achieved with optical technology. The amount of information that this technology handles is large, with a point cloud made up of 15 million points. Therefore, the management and calculation algorithms have to be optimized to the maximum. The Unimetrik pilot focuses on optical measurements for machinery components using M3, a high-performance software for capturing and analyzing point clouds. However, this parameterizable software provides different results depending on the expertise of the operator, and as it is designed as a black box, it makes difficult to verify those results and the process behind. Before starting programming the M3 software, it is necessary to design a strategy that depends on numerous characteristics of the physical part and parameters that the manufacturer requires. Usually, it is necessary to prepare a so-called measurement plan for each part by observing its characteristics and also establishing the key scanning parameters to capture the point cloud. On top of that, this measurement plan is designed only tacitly profiting the information that previous similar projects have with the object of study. Not only it is a waste of information, due to the know-how from previous projects being difficult to preserve, but also a waste of time, since it requires metrologists with relatively high experience, and this can be traduced as a gap in the process improvement and a suboptimal process yield. The main goal of Unimetrik applying XAI for smart semi-autonomous hybrid measurement planning is to increase the efficiency in the measurement plan definition by reducing errors and speeding up the execution of the measurement, as well as predict, based on certain key parameters, the level of reliability of the result. The Unimetrik Demonstrator will be focused in two main use cases. The first one, the measurement plan optimization, is aimed at retrieving a double benefit. XMANAI will contribute to reuse relevant information such as key parameters value configuration from previously performed jobs. XMANAI will help metrologists in identifying the correct values for the scanning parameters, but also to understand why and how they impact the quality and accuracy of the measurement. Experienced metrologists with extensive experience can identify which regions of the part component are the most relevant to be measured, and so, they are the ones that can adequately define the measurement strategy in the M3 software. This generates different results, accuracy level, and different time investments on the same measurement while performed by a senior metrologist and a junior metrologist. Additionally, different values for scanning main parameters, such as point cloud lateral density, scanning direction, and exposure time, result in measurements with different quality and accuracy. The second use case, the point cloud optimization, is aimed at generating a reduced optimal point cloud that will provide the best accuracy in the following analysis and processing of the point dataset. Nowadays, only experienced metrologists have the ability to identify which regions of the piece to be measured are the most relevant, and so, they are able to define accurate point sets. XMANAI will help in the knowledge transfer process from experienced metrologists to junior metrologists by not only optimizing the point cloud but also explaining the impact of those specific point sets on the final accuracy of the measurements. XMANAI Measurement Planning Manufacturing app consists of 4 tabs, namely, Point Deviation, X Deviation Model, Y Deviation Model, and Z Deviation Model, to provide predictions on global and per-axis errors in point capturing for the object under study. The starting point is a point cloud generated by a preliminary scanning with randomly selected conditions and scanning parameters. This is used as a reference point cloud to perform the inference for any scanning configuration. Results appear first in the Point Deviation tab, in the form of predicted error maps, and then on the other tabs, one per axis with explanations at local and global level depending on the selection of the user. The visualization of positive and negative errors follow the standard red and blue color, with close to zero errors depicted in green, in accordance with user intuition. Further, a permanent dictionary of input feature descriptions is included in the left side panel, as well as a converter of cosine values to angles in degrees. These features are added in the steady frame to facilitate the comprehension of the explanations by the end users without adding too much information on the actual plots. The Unimetrik Manufacturing app includes a scanning parameter optimization. The user, having already chosen the preliminary point cloud of the object under study, is provided with the option to either optimize the scanning parameters for the given object or to select them manually. If they choose to optimize the scanning parameters, then these will be automatically filled in once the optimization has finished. The benefits that the XMANAI platform and the manufacturing application that is being developed for Unimetrik are based on efficiency and accuracy, which are the main characteristics of the metrology as a quality control process for manufacturing. A testing and evaluation team composed by 2 junior metrologists and 2 experienced metrologists was selected for the testing and validation of the solution. Various demo sessions were held to retrieve the end-user feedback and to measure the main business KPIs. By solving the 2 use cases, key parameters and point cloud optimization provided, the XMANAI manufacturing application has delivered to Unimetrik a reduction of the time invested in defining measurement plans by 14% and also a reduction of half the errors of the measurements for both junior and experienced metrologist. It is highly remarkable that the XMANAI application had a relevant impact in the efficiency of the new explainable metrological process. It is highly remarkable the added value that the XMANAI platform is offering to the organization. A relevant impact in the efficiency of the new explainable metrological process has been identified. Moreover, by the use of explainable artificial intelligence, junior metrologist in Unimetrik will be able to effectively define a measurement strategy based on the understanding of the impact that the decisions have on the accuracy of the measurement. This is the actual knowledge transfer process that the organization is in need of. When considering the point cloud optimization, the XMANAI solution is aimed at generating a reduced optimal point cloud that will provide the best accuracy in the subsequent analysis and processing of the point dataset. Nowadays, only experienced metrologists have the ability to identify which regions of the piece to be measured are the most relevant, and so, they are able to define accurate point sets. XMANAI will help in the knowledge transfer process from experienced metrologists to junior metrologists by not only optimizing the point cloud but also explaining the impact of those specific point sets on the final accuracy of the measurements.
Soy Ainhoa Chavarri, trabajo en el Departamento de Aplicaciones de Unimetrik y una de mis funcionalidades es dar las formaciones sobre cómo trabajar con el sensor óptico en diferentes aplicaciones, por ejemplo la red no sería. Las formaciones, una de las cosas que es muy importante es qué parámetros usar en cada caso. Entonces, en el proyecto de XMANAI lo que nos proporciona es un aprendizaje más elevado de cómo usar los diferentes parámetros para optimizar los resultados. Y luego con el tiempo yo he estado haciendo experiencias para tener más autonomía.
Hola, mi nombre es Cristian Galán y pertenezco al equipo de Unimetrik. Desde Unimetrik nos hemos dado cuenta de que la inteligencia artificial allana el camino hacia la nueva metrología 5.0. Gracias a la aplicación de XMANAI somos capaces de reducir tiempos en los planes de medición. Con todo esto lo que conseguimos es una medición mucho más eficiente y más rápida.